And now I'm going to change this to a hole. So now I can see where this is inside the part, and I see that I don't have it where I wanted it really, so I'm going to move it in. Dave with the Crafted channel here, and look what we have. We have some 3D printed parts. This kind of is like two rod caps that go together. And I printed these last night. I designed this part in, I don't know, about 2 hours, I guess, and started the print job. And this print, it took about an hour and a half to print. This is a solid object. If I remember correctly, it's got something like 55, 60 yards of 1.75 millimeter filament in it, black filament. What is it? Oh, and I have not cleaned the supports out yet, but there's a clearance hole here for a socket head cap screw, 5/16, and on the other side there's a hex socket to hold a nut, and that's on both halves. So this gets clamped around a shaft. Well, what it gets clamped around is this item right here. This is a Harbor Freight lathe and mill combination, and it's owned by Bob Mullins, the Bison Workshop channel. And this is his first milling machine in the Bison Workshop, and he's really not using this for its lathe features. He's really trying to optimize how well this can work as a milling machine. Well, it's really got only a drill press handle here to run the spindle up and down, and that's too crude for a milling machine. You need to be able to move the spindle 5, 10, 15, 20 thousandths at a time in order to do milling, and so he's recognized that as a problem. Now this knob up here turns the spindle down slower. I'm not sure what the gear ratio is, but since it goes in here at an angle, it kind of looks like it's probably a worm drive on the spindle crank shaft. But he's installing a DRO, and that DRO is going to bolt right here, and it has to connect to this spindle housing, so when the quill goes up and down, he can get a readout of how far he's moved it. But the trick is, how does he connect it to this? He didn't want to drill this, so we talked about making a 3D printed part for it, and that's what I did. So here's the drawing he gave me to start with. And what he said was, this ring, let me ungroup this, this object right here, which is 89.97 millimeters, that is the diameter of this thick part of the column here, this thick part of the spindle housing, or the quill. And he wants something that grabs a hold of this. And this diameter here represents how thick he needs it to be in a section right about here, so that he can bolt on the end of his DRO readout strip. So I started with this simple drawing, just a disc or a cylinder here with another cylinder defined as a hole. And we grouped that together, which means applying the holes to the solids. Then we see what results here. Now the problem with this is there's no way to clamp it on or anything like that, and he just gave this to me as a basic guide to get started with, kind of a beginning plan. And he's unsure in this area here exactly where he's going to bolt that on, but it's somewhere from about the center out in here somewhere. So I'm going to show you my final drawing and deconstruct it for you, and hopefully there'll be some tips in there that'll help you draw some trickier things on TinkerCad. So here's the object that I drew. And notice I got rid of a lot of the thickness in places. We've got a split in it here, and we've got bolt holes. So this inner circle here is where the head of a 5/16 cap screw will go. And of course the small bore is a 5/16 bore. And then this recess here, this hex recess, is where the nut will be inserted. And then this is just a clearance hole for, I don't know, appearances. Eliminate plastic that's unnecessary. And we can see that that's in both sides of our part. And then I put my channel name in the part right here. And originally I had these corners rounded, but he said it would be more effective for him to use this if this was left flat. Now I'm going to do a Control C here to copy this object, and then a Control V to put it on the workspace. When you hold the right mouse button, you can scroll your drawings around. In fact, let me move my good drawing off of the workspace, and we'll put the one we're going to deconstruct on the workspace. Okay, so when you hold the right mouse button down, you can scroll your drawing around and even look at the bottom of it if you want in TinkerCad. And if you hold the Shift key down first before you hit the right mouse button, you can then slide the drawing around. So you need to be able to do both things to see it. So let's deconstruct this, and hopefully I'll remember everything I did here. I think there's a lot of, you know, kind of advanced concepts in how I did this that neat little tricks. So I'm going to ungroup the whole drawing to begin with. And I'm going to take this object out of the way. It's grouped by itself. Actually, let me put it back. Okay, I'm going to move it, and this is going to come into play later. I've got my snap grid set to 5 millimeters. I'm going to move it exactly 20 5-millimeter segments. So I'm moving it clear out of the way. Now this is what I constructed to make those bolt holes. Let me make a copy of this. I'm going to move it out here to the side. And let me show you what it's made of. I built this standing up, so let me stand it up. And it's setting 43 millimeters below the table surface right now, so I'm going to change that to 0, bring it up to the table surface. Now let's ungroup it. So here's what this object is made out of. You notice the lengths of a lot of these things are not critical. These cylinders are longer than they need to be because I end up making this object into a hole, and I need it to pass clear outside of my part. This is grouped by itself, so I'm going to ungroup that. We can see the parts that it is. This is just a hex of the right size for the nut. This represents the clearance hole to slide the threads through, and this cylinder here represents the head diameter of the fastener. So once you make these cylinders, all these pieces, you just hit this adjust, hit a line, line them up, and they're still highlighted. Now it's touching that part, but it's not highlighted. I'm going to group it. So now I have this part here, which would have, if I were to use just this, I'd have a hex hole coming all the way out, which to me doesn't look as professional. And then we'd have this really deep hole here for the head of the Allen bolt. Well, that doesn't really look very professional either. So I made a larger clearance cylinder for both sides of these. And when you see real collets machined out of metal, they're often made with all of these features. So I'm going to line these up. group. So now I've got my object. I'm going to turn it 90 degrees. And here's another interesting question. How did I get it in the middle of this block? Because if you look, it's really precisely in the middle here. There's really a couple different ways of doing it. I'm going to show you how I did it, which is probably the long way. Oh, I missed a step here. And remember, these objects you make in TinkerCad are all built out of other objects and holes. So in order to make something, you have to make several objects, and this was the object that I made to make my hole here and to hold all my fasteners. So I'm going to lower this down to the workbench, and this is the largest piece here. Both of these end pieces, and they're 17 millimeters. The thickness of our yoke here, or the thickness of our collar, I guess is the right word, is 25.4. So I need to move the middle of this up to 25.4. So the middle of 25.4 is 13.7, I'm sorry, is 12.7 millimeters. That's half of 25.4. Half of this number is 6.5. I'm sorry, is 8.5. So the difference between 8.5 and 12.7 is how far I need to raise this up off the table to put it in the middle. So let's see, that would be 4.2. So let me put 4.2 in here. Now I've raised it up off the table, and it should exactly match the part that I have in there, and it does, as you can see. So this was one of the necessary pieces to build, and let me show you where I found some of that stuff. Like, here's the cylinder that I ended up making into that, and we can make it the diameter we want just by changing these numbers here. Here's the hex, and you can change these numbers to get a hex shape like this to stack into your part. Now this is a little trickier because you notice that this dimension here, it's measuring from point to point on the hex, and this dimension here is flat to flat. So what I did was I just changed this dimension to get the right wrench size or the right nut size, but I kept track of the ratio of how I changed that, what the multiplier was, and then I altered this one by the same amount so that it would be the same dimensions all the way around. And I think it's 9/16. I don't remember exactly. But those two pieces and different diameters and different lengths is how I made this whole part. And notice that makes a lot of the features of this clamp-on collar here. So how did we make this shape? Okay, the first thing I'm going to do is I'm going to move this out of the way. Now my grid is still set to 5. I'm going to move it out 20 spaces. And there's a reason for that. So I can put that, now that I know I've moved it exactly 20 times 5 millimeters, I can go back and put it back where it was. That's exactly where it was. Now I'm going to get it out of the way again. Okay, now let's ungroup this and see what it's made of. Okay, so, wow. Made of an arch. Now I'm going to move this so you can see it. And the question becomes, how did I make that arch? Let me ungroup that side as well. Let me copy this arch and move it out of the way. And let's ungroup it. And look, I made it out of the same drawing that Bob Mullins made. I just stretched out its dimensions until the inside hole was the same width as the outside of my part down here, or just ever so slightly wider, because what I wanted to make was a hole to trim that part and give it a thinner cross section. So here you can see I took how I cut my part off. This is just a big block that I made into a hole. See that? So, and this is a hole that's in the center. So when we group all of this, that's all we have left. So let's get this out of the way. I'm just going to move it out of the way coarsely here. And let's delete this, and you can see what's underneath. It's just nothing but a puck. Let's look at the dimensions of this. Okay, let's put this back. And let's group this. Okay, so let's look at the dimensions of this part. And you notice it's 206.45 wide, 163.64 high. All I did was play around with these dimensions. I'll change this to 300 millimeters and watch how it gets stretched out. So you see, I can make that any size I want. So if I was working with a bigger part, I might stretch it out like that. Let me cut this off. Group. So now I just have this piece left, and by the way, I can just change the size of this piece. Let's say I want it even flatter. Let's cut this down to 50, and let's make this 300 even. So if I wanted to take a different arc out of something, or I wanted to build a different arch, I can just resize an existing part. I'll make it into a hole. And if I have an object that I want to put that curve on, here's an object. Let's say I want to shave off that part of the object, or let's say I want to pick up this shape over here. And that's exactly how I made this part downstairs. So I made this weird shaped solid object, and you can see the line where it's cutting through my original red object. When I group this, we see the basic part. How did I get the split here? That's pretty easy. The split, I'll raise this up. It's sitting on the ground now. I'll raise this up 30. The split is just a rectangle. And I took a rectangle out of here. I made it 3 millimeters in this dimension. I made it the height of my part, 25.4, and I made it the length, an extra long length, let's say 150. So now I cover the whole thing. Now if I make this into a hole, it basically works like a knife. Of course it removes a 3 millimeter kerf also. Let me group this together here and demonstrate that. So now you see I have this part cut here. I'll ungroup it so that I can take away the application of the hole. Delete that. So this is basically how I made this. Now, a couple more important tricks here. You drop this back down where it goes. You bring that back. And let's bring this back. When I originally drew this, oh, there's one more. When I originally drew this, I had the circle, and I had this block here in red. I've just got the color changed so it's a little easier for us to talk about it. I guess it goes there actually. And then when I wanted to trim off the wall thickness of this ring and put this part in here, and I grouped it, it cut off my mounting block feature. Well, that's no good. Now the crafted letters are up above that wall a little bit. So now what's he going to mount his DRO to? That's the whole point, is to have this tab. So the way I solved that problem was I took the objects that were required to make that standoff block and I grouped them together separately, and then I moved them out of the way. Let's ungroup that so you can see what it's made of. This is just two triangles, a square, and these letters. But in order to get my shape here, I had to move this out of the way. Now I can move it back. And regroup my object. And now my tab is there. Ah, but look, this block interferes in here. So let me show you how I solved that problem, because I made this mistake initially too. So we're going to ungroup this. And you don't only move things away, sometimes you move things vertically. I'm trying to get it to select that hole in the middle here. There we go, I got the hole. Now the hole's sitting right on the work surface at 0. I'm going to raise it up. So I'm going to raise it up, let's say 100. So we see the hole up above here. And so now I can do something else. I can group this together. This gives me my exterior shape that I wanted with the split. I'm going to move my block back in. And I'm going to group it together. Now I'm going to change the height of my hole. Oops, wrong one. I raised it up 100. I'm going to set it back down on the table by putting 0 in this box. So now the hole's back down there. So now I can apply the hole last. And boom, there it is. And the block that I used to form this mounting surface does not interfere with the hole. Now we can move our nut and bolt holes back in. Okay. You group the whole thing, and there we are. We have all of our fastener holes back, just like our finished part. Now I'm going to show you one more really cool TinkerCad trick. I'm going to ungroup this so that my holes, where my bolt holes are showing here. Now I'm going to change these to a solid color, so let's change them to yellow. So they're now solid, and now I'm going to change this to a hole. So now I can see where this is inside the part, and I see that I don't have it where I wanted it really, so I'm going to move it in. and get it very close to this internal bore. Now we can see right here there's just a little gap. Now when I originally positioned this, what I did was I set my grid to 0.1 millimeters. So now every time I hit my arrow key, it'll only move 0.1. And I slid this part over until I saw it peek through the surface. See it peeking through right here? Let's zoom in on that some more. There we go. So we're peeking through the surface. Now I moved it until it was totally inside, which is right there. Now the print head has a 0.4 millimeter diameter. It's its minimum width to print. I don't want to leave a super thin wall here because this could break. It would be a place for a crack to start. And I print this drawing with 3 shells, which means that there's 3 layers on the outside of the part that are parallel together before it does the zigzags on the inside to fill it in. So I wanted to leave room for those 3 shells here so I'd have a real tough surface. So since a shell is 0.4 millimeters and I want to leave room for 3 of them, I'm going to move this that away at least 12, and I'm going to do 1 more tenth. I'm going to do 13 tenths of a millimeter just for good measure. So that's 10, 11, 12, 13. So now I've got a little space here. 1.3 millimeters of solid plastic right here in this thin spot. Now as the interior wall comes around, it moves farther and farther away from the bolt, which I think I can show you here. So it becomes less and less of an issue. So let me move over here, and we'll reset this one the same way. So I'm going to move it till I see it peeking on the inside, just using my arrow key. There it is, it's peeking on the inside. Right there is where it disappears. Now I'm going to move it out 13 more strokes of the right arrow key, which is 1.3 millimeters. Now I could do it with less strokes, but then I would have to be clicking in here and changing this grid number an awful lot. Like if I change it to 1, it'll move 1. 1, 2, 3, 4, 5. Look at that. 1, 2, 3, 4, 5. And like I showed you, by setting the grid to 5, you can move a part out of the way a specific amount and move it back later after you've done some transformation of the part. So there's a lot of, I think, really handy TinkerCad tips for making mechanical drawings. If these videos are well received, I'll make some more. And here's our part back. Change the holes into solids and the solids into holes. We'll regroup it. Bam, there it is. So this is exactly the same drawing I started with, which is setting over here on the side. Another very good practice, if you're going to really mess around with your drawing, you're going to take it apart and go in there and fix something, it's a good idea to make a copy of it and work on the copy in case you get something screwed up or moved out of position. That way I can always go back to this as a starting point if I foul up my drawing and do it again. So that, my friends, is some good mechanical drawing tips. I'll put a link in the description and possibly up here on the screen to the Bison Workshop channel. He's down in North Carolina, and he's got a metal workshop inside of I believe it's a 30-foot camper. And a really talented guy, and he's trying to make a go of it. So give his channel some support, and I'm pretty sure he'll make a video about this part when he gets it and finish installing his DRO on the quill of his Harbor Freight combination mill and lathe. And these are the finished parts I'm sending him. And this jagged edge here, these are the supports. This was actually made up on the surface of the table like this. And so it builds up that support to hold up the top of this ceiling here, because the printer can't really print in air. It needs to print on top of the structure. You can see it doesn't support the whole hole, just the flat part at the top. There we go. There's a good view of that. This was made with a circle tool, by the way, that creates circles with facets. There's ways to do perfect circles too. Wasn't really necessary for this project. And this way I used the drawing that he started with. So I was able to use something Robert started with to produce a nice part. So there you go, another project on the Crafted channel. We'll get it in the mail now.